Hello everyone, welcome to the first lesson about calculus. Calculus, it's really important. It was a monumental achievement in the history of humanity. So we need to find out why is that important. So the first question is why? Why was it created? Calculus is created to describe how quantities change. So, for example, the growth of a population, the changing rates of a chemical reaction, all of these applications are really important. And calculus provides the tools to understand and predict these changes with precision. So it's crucial. But the second question is how? How we can do it? How can we find this quantity? There are two ways. The first one is differentiation. Differentiation is the process of finding the rate of change of a given function. The opposite is integration. Integration is the process of finding a function when we are given its rate of change. So differentiation, the function is given. Integration, the rate of change is given. This is really important. So in differentiation, we have the function and we have to find the rate of change. In integration, we have the rate of change and we have to find the function. So they're really important. They're different, but there is a big connection between them. So both of these are based on something really crucial: the limit of a function. So the limit of a function is crucial to find, to derivate, to integrate. This is a tool that we use to do it. So finding a limit, finding limits, it's the heart. It's the heart in calculus. We have to understand this concept very well. So before to give a definition, it's really important to understand what is a limit. Imagine to have this example. We have to describe the behavior of this function. Okay, this function close near to x equal to 1. Why? Well, this function is defined for all real numbers except x equal to 1. This because here this quantity has to be different from 0. So x cannot be 1. So close to 1, what can happen? This is the question. This is the concept of limit. Close to, near to, x equal to 1 in this case. So the graph of this function is a line, as we can see. With 1 point removed. So 1 point is not there, and this point is 1, 2. This point is not defined because it doesn't exist. So how we can draw when the point is not in the solution, just a hole in the graph. Okay, so for any x different from 1, we can simplify the expression. So basically, if we simplify, we can find that the function is just x plus 1. Okay, just we do this, x equal to 1. So in x equal to 1 is not defined, so we can simplify. Okay, so when x is equal to 1, so this is f1, is not defined, as we said, we can make the value of f of x as close as we want to 2 by choosing x close enough to 1. So we want to know what happened here in this part. So how we can write these concepts? In this way, the limit of f of x for x approaches to 1 equal to y, because of this. So when x approaches to 1, this one, epsilon is equal to 2. This is just a function. So it's the same concept. This is fx, this one. So the graph is this one, the correct one. Here we have a hole because it's not defined. X approaches to 1 is this one, and 2 is the value of epsilon. And this is true because here, close, the question was near x equal 1. So here is near x equal to 1. The value is 2. So let's talk about this exercise. So we have this limit, okay? This limit is not defined when x is equal to 1. So as before, we are asking to ourselves near x equal to 1, what can happen? If we try to put the value in this expression, we have 0 divided by 0. This form is not clear in our mind what is this quantity, but we can write this expression in another way. I can write in this way this expression, and we have the solution because the 0 divided by 0 form is not present anymore. So we have this, and with this substitution, put this inside. So we have 1 plus 1 and 1 plus 1 plus 1 equal to 3. So in the end, we have 2 divided by 3. So this is the solution of this limit. Thanks for watching, and see you in the next video about this course. Bye.